Hi guys, so today we're going to talk about the quadratic formula. The quadratic formula comes from the polynomial of the form ax squared plus bx plus c, and somebody decided they were going to complete the square on it, and they come up with the quadratic formula that you guys have probably know and memorized. But if you have not, let's do that right now. Remember, quadratic just means parabola for us. But what we are going to do, we are going to solve for x in this equation by using completing the square. So if we want to do this, we have ax squared plus bx plus c. So what we're going to do, we're going to subtract c to the other side, so minus c. Okay, then if we wanted to complete the square, remember this needs to have no term that has a in it. So we're going to factor a out of these two things, which means we have a x squared plus b over a x plus something minus something is equal to negative c. Okay, now if you're confused as to why we have b over a, just distribute the a back to the x squared and the b over a, and you'll see that you get back the original one. If you don't factor it out of the b, then you will have a term of a squared, you'll have an a added there, and you'll have ab as your abx instead of just bx. But if we're going to complete the square, we're going to take the middle term and divide it by 2. So we have b over a over 2 squared, which is going to be b over 2a squared, which I believe is simply just b squared over 4a squared, b squared over 4a squared, right? This is b squared. 2 squared and a squared. Okay, so here we go. We have factoring going on. So we're going to we're going to factor this. So this is going to be a parentheses x plus b over 2a squared. I know that that's what we put because that's what this is. Minus b squared over 4a squared is equal to negative c. Okay, so now we're going to multiply this a to both terms, this and this. So we have a times x plus b over 2a squared minus b squared, sorry, a times b squared 4a squared is equal to negative c. Well, that cancels with one of these. That leaves us with a x plus b over 2a squared minus b squared over 4a is equal to negative c. We're going to add b squared over 4a, and that's going to give us a x plus b over 2, oh, this should be an a, sorry, 2a squared is equal to b squared over 4a minus c. Let's get a common denominator for that right side. Common denominator here is going to be 4a, so we're going to have to multiply by 4a. So now we have a x plus b over 2a squared is equal to b squared over 4a 4ac. Well, right, because the common denominator is 4a, so we have to multiply by 4a on top and bottom because this is 1. Okay, so that's taken care of. So now let's divide by a. So now we have x plus b over 2a squared is equal to b squared minus 4ac all over 4a squared, because all you do is you drop this down and you multiply those together. Keep change flip. If you don't see it, then it's b squared minus 4ac over 4a divided by a over 1, and then you end up flipping this over. Okay. Then we have square root, so let's take the square root. So this is going to be x plus b over 2a is equal to plus or minus the square root of b squared minus 4ac. Well, this over the square root of 4a squared, which is going to be x plus b over 2a, plus or minus the square root of b squared minus 4ac. You cannot simplify any of that. All over, well, the square root of 4 is 2, square root of a squared is a. Then we are going to subtract b over 2a. And we have x is equal to negative b plus or minus, well, over 2a, plus or minus the square root of b squared minus 4ac all over 2a. Well, they both have a 2a on the bottom, so that's x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. And this is the formula you guys are used to. There is a song to memorize that formula. It's called the Quadratic Formula song. It sounds like Pop Goes the Weasel. I'm not going to sing it for you, unfortunately. Sorry. I don't want anybody to shut my video off early. But with that being said, that is the formula you will use. Now, if you go back to the original was ax squared plus bx plus c is equal to 0. So it has to be in this form to be able to use that formula. A will be associated with x squared, b will be associated with x, and c will be associated with the constant variable or constant coefficient. Okay, so with that being said, let's look at some problems. We have 2x squared is equal to negative 4x plus 1. Now, one important thing to note, the quadratic formula gives you the real solutions to the polynomial if they are not integers or rational numbers. This can be very helpful if you have like the square root of 7 as your root, because this can give you that. Okay, so this is already this is obviously ax squared is equal to negative 4. This would be whatever this is, bx plus c, which is not the correct form. So what we're going to do is we're going to move these all over to the other side. We have 2x squared plus 4x minus 1 is equal to 0. So I've added 4x and subtracted 1. Okay, this is this. So in this case, a is 2, b is 4, c is negative 1. Okay, so let's use the formula. X is equal to negative b, which is 4. So make sure you put parentheses around each thing you are substituting for. B squared, 4 times a times c. Oops, negative 1. Okay, all over 2 times 2. So this is going to be negative 4 plus or minus the square root of 16 minus 4 times 2 is 8 plus, times negative 1 is positive 8. So this is going to be, so minus negative 8, which is plus 8, all over 4. Okay, so then this is going to be negative 4 plus or minus the square root of 24 over 4, which is negative 4 over 4 plus or minus the square root of 24 over 4. I believe this is negative 1 plus or minus 24 is 6 times 4, which is 2 times 2, and this is 2 times 3, so this is 2 square root 6 over 4, which is negative 1 plus or minus 1/2, so square root of 6 over 2. So we get negative 1 plus square root 6 over 2, and we get negative 1 minus square root 6 over 2. Those are our two zeros for this polynomial. Okay, or this quadratic. That's the first one. The next one we will do is going to be number 2. We have n squared minus n is equal to negative 2. So the earlier part of this worksheet is going to be your different types of ways to get zeros for a quadratic. For instance, you might take a square root. You might use the square root rule. You might use factoring. That's another good way. You could graph it. And if you do those parts on the previous problems, you'll be able to do it. And so I invite you to try them and practice them using those other methods just to practice and remember how to do those things like factoring. But I am not going to show those in this video. If you need help, though, I will make another video to help you with those things. Okay, so let's get this in standard form, or we're just going to move this 2 over. We have n squared minus n plus 2 is equal to 0. So a is 1, b is negative 1, c is 2. Okay, so that means we have x is equal to negative b, which is negative 1, plus or minus the square root of negative 1 squared minus 4 times 1 times 2, all over 2 times 1, which is x is equal to 1 plus or minus the square root of 1 minus 8 over 2. 1 plus or minus the square root of negative 7 over 2, which I think is 1/2 plus or minus I square root 7 over 2. So this means this does not have any real roots. These are imaginary. These are your answers for this. I think that this is pretty... I hope that this is pretty easy to understand. If you get an I, that means that it's probably a graph that looks something like this. Okay, that means that it does not cross the x-axis, so that's why it would not be equal to 0 ever, which is exactly what happens when this is some number with I in it. So, it's either that or the following. It's one of the two. I hope this helps, guys. Make sure you're practicing and getting as much examples in as you can. As far as homework goes, I will be, I don't know, I haven't decided yet. I'll probably have you guys send me pictures of 3 homework assignments, or maybe even more than that. So make sure you're doing them. I hope you guys are doing well. Take care and goodbye.